Hey guys, tonight we're going to talk about the trig form of a complex number. Now the trig form also means polar form. So that's the first thing we got to think about. So we've been doing our polar equations and we have some conversion things we need to remember. So I'm going to put them up here in the corner. So we had r squared equals x squared plus y squared. We have x equals r cosine theta. Y equals r sine theta. And finally, tan theta equals y over x. So we're going to use these things to do the trig form of a complex number. So here we go. So let's draw a complex number, and let's just put it right here, right? And actually, I just need the dot, but I'm going to make the little triangle here. So this is my complex number, and I'll call it a plus bi. Now remember, this is the real, and that looks horrible. This is the real, and this is the imaginary. I'm using new software, so it's a little banged up, and I'll have to get used to it. So what we can do is, if I draw a triangle for this, right here, this is the A value, this is the B value. But A is really the X part. So this is really r cosine theta. This is r sine theta. And the hypotenuse is the r value. Remember, r is directed distance. So I can write this complex number in this kind of form. So here's our conversion. This is the part you must memorize. Z equals a plus bi is our complex number. So when we convert it, we're going to swap out the letters. And what we can do is we're going to factor out the r. So we have z equals r parentheses cosine theta plus I sine theta. And that's our conversion. So let's try one. So here we go. Let's convert to trig form, which is polar form. And let's just do nearest tenth of a degree. 4 minus 7i. So I want to convert this. So I want to write this in trig form. So now what I would do is this. I would sketch it. So I'm going to sketch this. Figure out where I am. Over 4, down 7. I'm down here somewhere. And I would think of it as a triangle. So it's 4 this way, 7 down. And what we're going to do is I got to find this is the r value. So now remember, r equals the Pythagorean theorem, right? R squared equals. So r equals the square root of 4 squared plus 7 squared. So we're going to crunch that out. So r equals rad 65. So we're halfway there. So now what we have to do is we have to find the angle. Now the angle I'm looking for is all the way like this. But I can't do that angle first. So what I'm going to do is I'm going to find this angle here. I'll call this theta to start with. And that's where we're going to use our tangent. So tangent theta equals y over x. And this theta I'm going to find is going to be my reference angle. So from here, the tangent would be 7 over 4. And so I'm going to use a calculator. So second tan 7 over 4. Punch that in your calculator, and you're going to get 60.3 degrees. That's the reference. Now you have to drop it into the fourth quadrant. So if that's 60.3, this whole other angle is going to be 299.7. And now we're ready to write it. So here we go. Z equals R, which is rad 65, cosine 299.7 plus I sine 299.7 and close parentheses. Now, to go the other way is even easier. If they give you this crazy radical 65 thing. You just distribute, and then either use, if it says decimal, use decimal, otherwise use special triangles. So let's try one of those. So let's try the other one. So this time we're going to convert again, and we're going to do it two ways. So convert to simplest radical form. And also, so that's A, and also part B, to, let's just say nearest tenth. So let's get a problem here. Let's pick, this is a good one, 3 cosine 30 degrees minus I sine 30 degrees. So what you're going to do is we're going to distribute the 3 to both parts. So it's going to be 3 cosine 30 minus 3I sine 30. Now, since this is a 30, I need a special triangle. So it's 1, 2, rad 3. That's 60. So the cosine of 30 is rad 3 over 2. It's 3 times that, so I'll put a 3 out front. Minus sine of 30 is 1/2. So this would be 3I, and the sine of 30 is 1/2, so it would be over 2. So this would be part A, simplest radical form. Part B, if I was going to do this, I would just type this right into the calculator. And you just type it in. You can do it in one shot if you wish. And you're going to round the decimals, and you're going to get 2.6 minus 1.5i. Or you can type in what your answer for the first part was. Either way, it all works. So let's try like 3 more problems. You're going to try 2, try 3 on your own and see what you get. So the first one. Why don't you convert this? All right, so the first one, convert to the nearest degree, to degrees, convert to degrees, and once you convert that to also radians also. So you're going to get 2 separate answers. And we'll use this one as 3 minus 3i. And let's do another one. Why don't we convert to complex form, and why don't we do exact value? So we'll do exact value. And why don't you do to nearest tenth also? So both ways. And let's get this one. Let's do a hard one. This is a bit tricky one. 5 cosine, 5 times, cosine negative 60 plus I sine negative 60. So hit pause, try them, and I'll put the answers up. Good luck. So that's the answer for the first one. So I wrote it two ways, in degree form and in radian form. Remember, pi equals 180 degrees. That's how I made the conversion. So make sure you do the next one. Here's the two answers. All right. So hope it's okay. We'll do some problems when we come back.